Okay, we're going to be looking from our textbook, page 99, activity 8c, the last of our kinematic equations. Question 1, a skateboarder accelerates uniformly from a standing start. So let's come up with our guess. Our skateboarder starts from rest, so his initial velocity is equal to 0, and he accelerates at 1.5 meter per second squared, and he skates for 4 seconds. What is his speed? What is his final speed? Is unknown. What is his final speed? We don't know. What's an equation which fits just these 4 things together? We've got v final is equal to v initial plus at. V final is equal to initial velocity 0 plus acceleration of 1.5 times time of 4 is equal to 6 meters per second. Note again, make sure you've got your units in there. Second question, we've now got a windsurfer, and he is initial velocity. He's initially going at 4 meters per second, and a gust of wind comes along and accelerates him up to a speed of 10 meters per second. And this takes 50 seconds. 50 seconds. So that's our givens. Our unknown is how far does he move? Distance equals, we don't know. What's an equation which ties all of those together? I've got all of my equations. I just laminated them in a sheet so that I can have a quick look at them. An equation that could draw those two together is displacement is equal to initial velocity plus final velocity divided by 2 times time. Initial velocity 4 plus 10 over 2 times 50. The displacement is going to equal 350 meters. To B, what is his speed after 30 seconds? After 30 seconds. Well, let's use our guess again. What are we given? We're given the initial velocity was 4 meters per second. 4 meters per second. We're given the final velocity. Sorry, we don't know the final velocity. We're given the time is equal to 30 seconds. Those are our givens. We've got a velocity, we've got a time. We've only got a velocity and a time. The unknown is his velocity after 30 seconds. We don't know. So we can't have an equation with just 3. We need another value in here. And what I suggest is that we go back to 2a, and we can from 2a, given initial velocity, a final velocity and a time, we could actually find the acceleration. We know the distance now is 350, so we could find the acceleration. So we've got an initial velocity. That's no longer our final velocity. We don't know our final velocity, but we've got an initial velocity of 4 meters per second. We've got a time, and we know the displacement. Sorry, that we do have the final velocity. So we could find the acceleration. We could use an equation for that. We could use v final is equal to v initial plus at. V final in this case was 10 meters per second. The initial velocity was 4 plus acceleration we don't know times 50 seconds. It's acceleration. Therefore acceleration is equal to 6 divided by 50 is equal to 0.12 meters per second squared. So from the first question we've now got an acceleration. It's the same windsurfer in the first case. So our acceleration, we've also got 0.12 meters per second squared. So in our second question, we've now got an initial velocity of 4. We're saying how fast is he going after 30 seconds, and we've retrieved the acceleration from the first part, and we need a v final. So what's an equation we can have for this? We can have v final squared is equal to v initial squared plus 2 times a times d. That's one of our equations there. Wait a minute, we don't have a d. We've got v initial, time, acceleration, and v final. We don't have a d, so we can't use that equation. So let's go back to v final is equal to v initial plus at. So v final is equal to v initial 4 plus our acceleration, which we retrieve from the second part, times time of 30 seconds is equal to 4 plus 3.6 is equal to 7.6 meters per second. That's his velocity after 30 seconds. 2c. What is the wind surface average speed for the 50 seconds? For 50 seconds, average speed, v average, is equal to distance divided by time. We've worked out that the distance was 350 meters and the time it took was 50 seconds. So the average velocity is 7 meters per second. Number 3. A ball is rolling down a slope, initially starting at 0.5 meters per second. Initial velocity is equal to 0.5 meters per second. Rolling down a slope, accelerating at 0.25 meters per second squared. How far does and it rolls for 4 seconds. What's the question? How far does the ball roll in this time? So we don't know distance. What's an equation which ties these 4 variables together? Displacement is equal to vi plus a half at squared, vit plus a half at squared. Have a look at our equations. vit plus a half at squared. Displacement is equal to 0.5 times 4 plus a half times 0.25 times t squared. 4 squared is equal to 2 plus 2 plus 2 is equal to 4 meters. Number 4. After stopping at a station, a train accelerates at a steady rate of 0.25 meters per second. After stopping at a train, so therefore its initial velocity is going to be 0. We're given the acceleration is 0.25 meters per second squared. How far does the train travel in 2 minutes? The time is 2 minutes. How far does it travel? So that's our givens. Our unknown is distance. What's an equation which ties these 4 things together? An equation. Distance equals again vit plus a half at squared. Now, these ones seem to be thrown in here just to trick us a little bit, although it is real world questions. 2 minutes, what's our units for time? Seconds. So we've got to make sure we've converted this to seconds. So 2 minutes is equal to 120 seconds. We've got to use that in our equation. So again, our distance is equal to 0 times 120 plus a half times 0.25 times 120 squared. Therefore distance is equal to 1800 meters. Again, don't forget your units. Okay, I particularly like this one. We've got an airplane that's coming in to land. It touches the runway traveling at 360 kilometers per hour. I think that's a little fast actually. I think they tend to come in more like 200, but anyway. So that's 100 meters per second. An airplane touches down at 100 meters per second and it comes to a stop. And the distance it travels is 1.5 kilometers. So how long does it take? So what is it we know? We know an initial velocity, 100 meters per second. We know a final velocity, 0. We don't want it to run off the end of the runway. We know a distance, 1.5 kilometers. Our unknowns is time. So what's an equation which ties those together? Equation is going to be d is equal to v initial plus v final over 2 times t. Solve that for t, substitute in our values, again making sure we've got the units right. So our units are meters per second, meters, so that's 1500 meters. So let's substitute in our values there. Distance equals initial velocity 100 plus 0 over 2 times time is equal to 1500. Solve that. Time is equal to 30 seconds. There you go. I like this one too. We've got a drag racer. A friend of mine used to drag race cars down Mary south of Auckland. Dragster travelling at speed accelerates uniformly at 7 meters per second squared for 8 seconds, reaching a new speed, a final speed of 85 meters per second. Now we don't have an initial velocity. We don't need to know that. That's our givens. Our unknown, we're asked to find what distance did you cover. Again, what's an equation which ties these together? An equation, it's this one here. Displacement is equal to v final t minus a half at squared. So displacement is equal to final velocity 85 times time 8 seconds minus a half times acceleration 7 times time squared times 8, so it's 8 squared. So that answer is going to be, work it out, 456 meters. That's the amount of time that it's got. That's the amount of distance it's gone. So that's all of the equation. That's all of the problems from activity 8C. I'm going to continue with another one in a moment.